This is Unit 3, Lesson 6, Graphing Equations when they're in standard form. In the previous lesson, you learned how to graph equations when they were in slope-intercept form. Now we're going to be looking at equations that are in standard form and graphing them. We can do it one of two ways. We can either convert that standard form into slope-intercept form and be able to graph them, or we can use the x and y intercepts. So those are our objectives for this lesson. Before we begin, let's do a quick review. Here we have two lines off to the right, Z and P. Line Z, is that a horizontal or a vertical line? Notice that it's going up and down, just like a vase goes up and down. Remember vertical vase to help you remember that a line that goes up and down is vertical. Line P, then it would be the opposite. A line that lays down on the ground, like where you see the horizon, is called a horizontal line. A line with a slope of 0. If you think of a little boy who's trying to go down a slide that's flat, he's not going anywhere. He's not very happy, but at least he's okay. So that's a horizontal line. A line that goes straight up and down, well, you couldn't slide down a straight up and down line. So that is no slope or undefined. So vertical lines are always undefined. So one of your objectives, as I said before, is to be able to convert any equation into standard form. In this equation, in this example right here, we have a line that is in point slope form. We can recognize that it's in point slope form because it has parentheses. So whenever you see parentheses, you pretty much can assume that it's in point slope form. So if you have an equation with parentheses, what do you normally have to do? Distribute. So if we distributed, what would we have to do? Well, we'd have to multiply that negative 1/3 inside the parentheses. Now, on this problem right here, they say that another way you could do that is that you could multiply each side by -3. The whole point of doing that is to get rid of that denominator. If you multiply each side by -3, it cancels out that denominator. But you still have to do distribution again. So even though on this slide it does have this where you can multiply each side by 3, it's actually creating more work. If you would just distribute, is probably the step that I would use right here. So I'm going to cross this out, and you can do this too. There we go. So we're going to convert this to standard form. I'm going to rewrite the problem. To convert this to standard form, we would have to use the distributive property here to get rid of the parentheses. Y minus 2 is equal to -1/3 x. A negative times a positive equals a negative. Just a minute. Sorry about that. Okay, so -1/3 times positive 6, as I said, was a negative. And then you need to multiply 1/3 times 6. I'm going to do that off to the side here. 1/3 times 6. Remember, when you multiply a fraction to a whole number, you just simply put a 1 underneath the whole number. You could either cross cancel or just simply multiply straight across and reduce. Let's do that for right now. So 1 times 6 is 6 over, sorry, I ran off the side there just a second. There you go. So 1 times 6 is 6, 1 times 3 is 3, but that reduces 2, while 6 over 3 is just 2. So 2. We still need to get, okay, so this is to get it into standard form. If you were to get this into slope-intercept form to graph this, you would simply move the 2 to this side of that -2 to that side of the equation as a +2. But this problem asks you to actually form it into standard form. We would bring this 2 over as a +2 still. So y is equal to -1/3 x minus 2 plus 2. That's a 0 pair, so it's just 0. You could put plus 0 if you want, or not write anything there. Let's go ahead and put a plus 0 for right now. This right here is y equals mx plus b, or slope-intercept form. So the directions say to write it in standard form. Standard form is when you have your x term plus or minus your y term equaling some number, your constant. So in this case, if we want to make this in standard form, we would want to take your x term, that negative 1/3 x, and move it to the other side of the equation. I'm going to do this down below here. I know they give you little spaces to write in the numbers. So if we bring the negative 1/3 x to the other side of the equation, that would be a positive 1/3. So positive 1/3 x plus y, that's that y that's already on the left-hand side of the equation, is equal to 0. And that right there is what we call standard form. So the first part of this lesson is how are we going to graph from standard form? Well, one method is using intercepts. So here I've given you a problem or an equation that's in standard form, because we have our x term plus or minus our y term equaling a constant. If you were going to graph in this form without converting it at all, you would have to find its x and y intercepts. Remember, the x and y intercepts are simply when x and y are equal to 0. So step 1, it says find the y-intercept. Well, that's when x is equal to 0. So what you would have to do is plug in or replace x with 0. I'm going to do it, let's see, up here. Let's see if I have enough room. 4 times 0 plus 2y is equal to 14. Well, when I plug in that 0, it's going to be always a multiplication, so it'll always cancel out. So you're left with 2y equals 14. If you divide both sides by 2, y would then equal 7. So the y-intercept is 0, 7. If you were to plot that, 0, 7 is right there. It's on the y-axis. That's why it's called the y-intercept. The x-intercept, I'll go ahead and solve that one down below here. We have 4x plus 2. Instead of replacing the x with 0, now we replace the y with 0. Equals 14. Hopefully you're writing this down on your paper too. So there's that multiplication of 0. It'll always cancel out. And now we want to get the x by itself by dividing by 4. Make sure I copied it right. Yep. So we have x is equal to 14 over 4, which doesn't come out even, so you just have to reduce it. 14 over 4 reduces to 7 halves. If you do this on a calculator, what is that, 3.5? Which is not super easy to plot. So where would be 3.5 be located on the x-axis? 3.5 would be right, let's see if my pen will let me do it, right about there. So 3.5, 0. Then we just simply connect the 2 points together and draw your straight line with the arrowheads on the end. Let's try one more practice of this. To find the x and y intercepts, we simply replace the x and the y with 0. It's always a multiplication of times its coefficient, so it sort of cancels out the term. In the step 1 it says solve for the y-intercept. Well, you could just simply cross off that x term because you're going to be replacing it with 0. It's going to equal 0, so it's like it's not there. So you divide both sides by 2. You'll get y is equal to negative 6 over positive 2 equals a negative 3. So you would plot the point 0, negative 3, which is right there. Alright, if you were to solve for the y-intercept then, you simply, or the x-intercept, I apologize, you simply cross off the y term. And you see x is equal to -6. Pretty simple. So you can use that method of just simply crossing off the term when you're solving for your x and y intercepts. And so our x-intercept at -6 is located right there. Remember, x-intercept will always be on the x-axis, the y-intercept will always be on the y-axis. Connect your points together. I did that pretty sloppily, but you would have a ruler when you did these. And don't forget to draw your arrowheads. The other way of graphing a line from standard form is to first convert it to slope-intercept form. So here we have an equation of a line, 8x plus 3y is equal to 12. Remember that your slope-intercept form is y equals mx plus or minus b. I'll go ahead and put a minus sign there, plus or minus b. Often in books you'll just see plus b. So what you'll need to do is solve for y. The first step is you'll need to move your x term to the other side of the equation right after the equal sign. Let's see, where can I do this at? I'll try doing it up here at the top of the page. 3y is equal to, don't forget to change that sign, -8x plus 12. Are you writing this down on your paper? Then to get y all by itself, because we have a 3 beside it, what do we have to do? Divide it. Remember that when you divide, you must divide every term by that 3. So y is equal to, because those 3's will cancel out, that was the whole point of dividing by 3, -8 thirds x plus 4. Right? So that is our slope-intercept form. To graph this is actually a review from the last lesson. You will need to identify your y-intercept. Remember, that's the value that's either being added or subtracted to x. It's the value that becomes part of your y-intercept, or the y point, but when when x is equal to 0, y is equal to whatever values the added or subtracted at the end of that equation. And it's also the point on the y-axis. So you would plot a point right there. Then you have to use your slope. Remember, your slope is equal to the fraction that's in front of your x term, or the coefficient of x, so -8/3. That 8/3 represents the rise or fall, if it's negative, which in this case it is, over the run. And remember that we always run right. So from the point that we begin with, the y-intercept, we will count down 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm down here at -3. And I run right to 3. 1, 2, 3. So it looks like it's right there. Connect your dots. Draw a straight line, much straighter than I can draw with my electronic pen here. And there's our line. Double check your line. You can double check this by looking at your slope. Notice that my slope, I have a negative slope, so I should expect my line to be going downhill. If you were to write your name on your line, do you see that your line is going downhill? So that's a good check to make sure you did graph it correctly. Alright, let's try one more of these practices before you do your group practice problems. And on the next file, you should be able to check your answers to make sure you've done them correctly before going to the next lesson. Focus question 4 says 3x plus 2y equals 4. So look, what would be the first step to getting it into that y equals mx plus b form? Do you remember? We need to first move your x term. So you should have 2y is equal to -3x plus 4. You still have to get y all by itself, so what would you have to do next? Divide by 2. So y should then equal -3/2 x plus 2. What is your y-intercept? Because that's where you need to begin with. Always begin with your b value. Our b value is 2, so the y-intercept is 0, 2. You plot that point right there. Make sure it's on that y-axis and not the x-axis. And then you use your slope. Our slope is equal to negative 3/2, which is the rise or fall. Is this a rise or a fall? Did I just do this one? I feel like I just did this one. Over the run, and always run to the right. No, we didn't do this one. It just looks like it is. So we go down 3, 1, 2, 3. It looks like I'm at -1 and over 2, 1, 2. Once again, we have a negative slope, so your line should be going downhill. There you go. Checked your slope. Should the graph be going uphill or downhill? It's a negative slope, so it should be going downhill. Since there's only 4 group practice problems, I'm not going to make a separate file for this. Go ahead and attempt all 4 of these problems on your own. Push pause on the video, and when you are done, push play so you can check your work. You may use either method that you prefer, using the x and y intercepts, or converting to slope-intercept form and graphing with the y-intercept and the slope. You'll find that sometimes one way may be a little bit easier to graph than others, especially when you get fractions for answers. If you find it difficult to graph one way, then you might want to consider the other method. Go ahead and attempt all these, push pause, and push play when you're ready. Alright, you sure you're ready? You've done all 4 of these and you're okay. Alright, question number 1 says x plus y is equal to 3. Looking at this problem, like I said, sometimes one way may be easier than the other. When I don't see any coefficients at all on a problem, I generally will use my x and y intercepts. They're very simple to see. Notice if we find out what our x-intercept is, I can just cross off my y and I see x is equal to 3. That's my x-intercept. If I want to find out what my y-intercept is, I simply cross off the x term and I get y is equal to 3 as well. So I graph both of those points, 3 and 3, and draw my line. And that's what it should look like. Now if you did change this or convert it to slope-intercept form, let me go ahead and change my pen color so you can see what you would need to do. You would just need to move this x term after the equal sign, so you would have the equation y is equal to negative x plus 3. You would still graph that y-intercept at positive 3, so this point right here. And then you would have to find your slope, which is equal to -1, because there's a 1 in front of that x when you don't see one, over 1. So you'd have to go down 1 over 1, and there's the next point. Yeah, I know my line isn't super straight, but it should actually go through that point there. Alright, so there's the same line. It's supposed to be the same line. Okay, so just a few extra steps. So that might be a helpful hint in the future. If you notice there's no coefficients or numbers in front of your x and y term and it's in standard form, to just go ahead and use your x and y intercepts. Just cross them off to solve for each one. Let's look at number 2. This one does have coefficients. You see a 10 and a -3. Again, it doesn't matter which method you use. We can use x or y intercepts, but if we start getting fractions for your x or your y intercept, then I maybe would convert this to slope-intercept form. So first method I'm going to demonstrate then is finding the intercepts. To find my x-intercept, I'll just simply cross off my y term, and you'll get 10x is equal to 15. To solve for x, I have to divide by 10, divide by 10. So x is equal to, well, 15 over 10 doesn't come out even. It comes out to what, 3/2? And what is 3/2 equal to? I think it's 1 1/2. So graphing 1 1/2 on the x-axis would go right about here. And then to find my y-intercept, I'd have to cross off my x term. You'll get negative 3y is equal to 15. Divide by negative 3. So y is equal to, I have a positive over a negative. Did you remember to watch your signs there? Equals a negative 5. So negative 5 would be right there, and then draw your line straighter than mine, like that. If you decide to convert this to slope-intercept form, you would have simply needed to move your x term to the other side of the equation. So you would have negative 3y is equal to negative 10x plus 15. Divide both sides by negative 3, or all terms by negative 3. So y is equal to, a negative over a negative is a positive. 10 over 3 does not reduce, so it's just 10 over 3. X, a positive over a negative equals a negative 5. So you would first plot your y-intercept, which is that negative 5. So I go over here to negative 5. Notice we still have the same y-intercept, so that's a good sign if you find the same point there. And then use our slope. The slope is equal to 10 over 3, or a rise of 10 and a run of 3, and we always run to the right. So we go up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That puts me at positive 5. And to the right 3, 1, 2, 3 actually puts me right here. And because my line isn't that straight, that's the reason why my blue line's not really going where it's supposed to be. But it is supposed to be the same line. Straighten up my blue line there so that it looks like it's the same line. So it doesn't matter which method you use, just make sure you are familiar with both methods when you're looking at standard form. On the ECAs, it might ask you what are the x and y intercepts before it'll even ask you to graph the line, so you do need to know how to do both methods. Question number 3, we have 2x plus y is equal to 4. So one of those numbers has a coefficient 2, or one of those terms has a coefficient, and that's the x term. This would actually be an ideal problem to put into slope-intercept form because y is almost already by itself. You just need to move that 2x to the other side. So you'll have y is equal to negative 2x plus 4. And then you're already ready to graph this. So that's why I would prefer to use the slope-intercept form to graph this one. You plot your positive 4, or your y-intercept, and your slope is equal to negative 2, or negative 2 over 1. So you would count down 2, that puts you at positive 2, and over 1, so there's your other point. Draw your line, and then you'll be done. Now if you did use your x and y intercepts to graph instead, that's fine. Change pen colors for. The y-intercept's pretty easy. If you cross off your x term, y is equal to 4, so there you get that same point up there of your y-intercept of 4. If you are looking for your x-intercept though, you cross off your y term and you get 2x is equal to 4. So you'd have to divide both sides by 2. And your x would equal 2. So that's your x-intercept, which is located right there. Again, my line isn't super straight, but then you would just connect those 2 points together and you should get the same line. Finally, your last problem, x plus y equals negative 3. Again, as I said before, if you see no coefficients on your x and y, I think finding the intercepts are much easier than using slope-intercept form, because if you cancel out 1, there you go, x is equal to negative 3, so you just plot that point there. If you cross out the other one, y is equal to negative 3 as well. There's your 2 points, connect your dots, and you're done. Pretty simple. If you use slope-intercept form, that's fine. You just have to take a couple extra more steps. Oops, meant to use my eraser there. Use some more extra steps here. You would have to move your x term to the other side of the equation. So y is equal to negative x minus 3. Your y-intercept then is negative 3, that same spot down there. Your slope is equal to, well, it's the coefficient of x at negative 1 over 1. That means we'd have to fall down 1 and run right to the 1, so that you should have a point then right here if you use that method. Connect your dots and you should have the same line. Right. That's the end of this lesson. You also have some practice on this on your homework. Go ahead and continue to lesson 7.